Hi, it's Alex from EDD Academy, and I'm just checking in to say that you may have noticed that my last SAT video, SAT practice test number 3, was split into two parts because when I filmed it all in one go, the video came out to be about 48 minutes, so I decided to cut it at the halfway point just to make it a little easier on you guys. And yeah, so enjoy questions 11 to 20 in this next video. Thanks. Question 11 says that in the figure above, lines K, L, and M, K, L, and M, intersect at a point. If you say, if x plus y, and those are angles, if x plus y equals u plus w, which of the following must be true? Okay, so we will go about solving these or trying to verify these in order, and then if it's valid, we can cross out the ones that don't include the certain option, and if it's not valid, we can cross out the options that do include it as valid. Okay, so these angles here, y and u, they're vertical angles, and by a vertical angle theorem, what vertical angles are is they're equal. So we have that y equals u. Thus, we can substitute this in the equation to give us that. So we have that x plus y equals u plus w. But what is u? We just said that u is y. So we can rewrite this equation as x plus y equals y plus w. But if we subtract y from both sides, it cancels. So we have that x equals w. So we know that these are equal, right? And by symmetry, if these are equal, then z and t are equal. And now we can go about solving the question. So, x equals z, is that true? So, if x and w are equal, and z and t are equal, we can set up a proportion, or an equality as well. So that means x equals z, and w equals t. So yes, question 1 is correct. What about the second Roman numeral, y equals w? We only know that y is related to u and nothing else. So y is not equal to w. So that is false. And we can cross out, all of the choices then. We don't even need to prove number 3 because answer choice A, C, and D all include number 2 being true. So our answer choice that is correct is answer choice B. Okay, so in the quadratic equation above, A is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD. And the question asks, which of the following is equal to D? So we have this equation here, y equals a times x minus 2 times x plus 4. And if you know anything about parabolas, this means that the parabola, so in a factored form like this, these two roots here is where the parabola crosses the x-axis. It's where their y value equals 0. Okay, so it crosses the axis. I said it crosses the x-axis at x equals -4 and x equals 2, or the points -4, 0, and 2, 0. And if we consider the symmetry of a parabola, the x-coordinate of the vertex of the parabola, I'll draw it out here, let's say this is just a generic parabola equation, the vertex is halfway in between where the parabola crosses the x-axis. So you have a point here, and the vertex is the x value halfway in between them. So that means the x-coordinate, the c value of our vertex, is just the average of the points. So -4 plus 2 over 2. So that means c equals -1. And now that we have a c value, or an x value, in this equation here, we can just plug in and solve for y. So we have that y equals a times -1 minus 2 and -1 plus 4. So that says that y equals a times -1 minus 2 is -3, and -1 plus 4 is 3. And multiplying this all together, we have that y equals -9a. And like we said, d is y in this case because c was x, so d equals -9a. Answer choice A is correct. Question 13. The equation 24x squared plus 25x minus 47 all over ax minus 2 equals -8x minus 3 minus 53 over ax minus 2 is true for all values of x not equal to 2 over a, where a is a constant, and it asks what is the value of a. Okay, so let's see, how do we go about this? Well, we have this as, we know the general form of this division, right? So 24x squared plus 25x minus 47 divided by ax minus 2 is -8x minus 3 with a remainder of 53, right? Thus, -8x minus 3 times ax minus 2, because we divided this numerator by this to get this. So if we multiply these two and subtract the remainder, we should get this, right? So minus 53 equals 24x squared plus 25x minus 47. We can rewrite this, we can factor this out, or expand this out, and we get that. So -8ax squared, and then we FOIL this out too, plus 16x, FOIL this, the inside now, minus 3ax, and then finally, our last term, plus 6, don't forget this minus 53, equals 24x squared plus 25x minus 47. We can simplify this to -47 and ignore this term for now, and note that this x squared term has to be equal for both sides of the equation. So we can ignore this stuff and just say that -8ax squared must be equal to 24x squared. And because they both have an x squared term, we can just cancel that. So -8a equals 24. And if we solve for a, divide both sides by -8, we have that a equals -3. Answer choice B fulfills that solution. Question 14 seems more simple than the rest. what are the solutions to 3x squared plus 12x plus 6 equals 0? So immediately, I see a factor of 3 in each of these terms, so I'm going to factor that out. So first, I'll just rewrite this, and then factor the 3 out. So factoring the 3 out of this is just dividing this term by 3, because that's what factoring is, it's dividing out. So that's just x squared. 12x divided by 3 is 4x, and then 6 divided by 3 is just 2, and then equals 0. Then we can divide both sides by 3, get rid of it, so we have that x squared plus 4x plus 2 equals 0 over 3, and that's just 0. So you can take some time to look at this, and whether you can recognize it immediately or not, this is not factorable. So we're going to need to use the quadratic equation, which says negative b plus or minus the square root of b squared minus 4ac all over 2a gives us our solutions, where and this is for an equation of the form ax squared plus bx plus c. So each of the values in our equation correspond to this, so a equals 1, b equals 4, and c equals 2. If we rewrite this, we have that negative 4 plus or minus the square root of 4 squared minus 4 times a times c, so times 1 times 2, all over 2 times 1, which is just 2. If we simplify this, that's negative 4 plus or minus 16 minus 4 times 1 times 2, which is 8, all over 2. And that's negative 4 plus or minus root 8 over 2. Canceling this here, we have a factor of negative 2 on the top, so we can just cross out that. And square root of 8 is clearly not square root of 30 over 3, so answer choice A is correct. Question 15 reads, the equation above shows how a temperature F, measured in degrees Fahrenheit, relates to a temperature C, measured in degrees Celsius. And that's this relationship up here. And based on this equation, which of the following must be true? So how we approach this question is similar to, I believe it was question 11. It was a question a couple slides ago where we try to evaluate each of these Roman numerals and just see if they're true, and then we'll go about choosing an answer choice after we've done that. So Roman numeral 1 says a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degree Celsius. So looking at our graph here, looking at our equation here, we see this is in slope-intercept form. If we expand this, we don't even need to expand this last term, but if we expand this is our slope in slope-intercept form, right? And then this is going to be our y-intercept. So if we plug in 1 degree Fahrenheit, like the statement asks, what are we going to get increase in Celsius? 5/9, right? Because 5/9 times 1 is just 5/9. So statement 1 is correct. So we can cross out B and C, and then we can look at statement 2. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. So if we test this, so 1 degree Celsius, what does this mean? It means that we're trying to look at the inverse relationship of the equation we're given. We're trying to look at Fahrenheit in terms of Celsius. So this is equivalent to saying that 1 degree Celsius, so plus 1 Celsius equals 9/5 Fahrenheit, right? And 9/5, if you simplify that, That's just 1.8 degrees Fahrenheit. So number 2 is also correct, meaning D is our answer. So moving on to the free response questions. The question says, so we have this given equation, and if x is greater than 0, what is one possible solution to the equation above? So that probably means there are multiple and we have to choose one. So this equation, let's write it out like this. Immediately, I personally would expand this because I like dealing with an unfactored form if we're looking for solutions at first. So if I expand this, we have x to the fifth minus 5x cubed. And I also want to take this negative 4x and bring it to the left side so we have all of our x terms on one side of the equation. So plus 4x equals 0. And now we can refactor. A common term in all of these is x, so we can factor out an x. And like I said, factoring out means just dividing from each term. So x to the fifth divided by x is just x to the fourth, minus 5x cubed divided by x is just 5x squared, and 4x divided by x is just 4. So, and that still equals 0. Now, we can refactor this interior expression into x times x squared minus 1 times x squared minus 4 equals 0. Once again, this factors even more because these are both differences of squares. And a difference of squares says that x squared minus, let's say, a squared equals x plus a times x minus a. Okay? So this factors to x times x minus 1 times x plus 1. And then if we apply the same tactic to x squared minus 4, we have x plus 2 times x minus 2 equals 0. Thus, our solutions are x equals 0, x equals 1 from this, x equals negative 1, x equals negative 2, and finally x equals 2. And we look at the question again. It asks if x is greater than 0, so we can cross this, this, and this out. Our possible solutions are 1 or 2. Okay. Question 17 gives us an algebraic equation. If 7/9 x minus 4/9 x equals 1/4 plus 5/12, what is the value of x? So rewriting this here, immediately we see that we do not have common denominators, and with fractions we always want to have common denominators to just make them easier to work with. So the least common multiple of each of these, it looks like, is 36. So we want the denominator on every one of these terms to be 36. So that would mean multiplying this 7/9 x term by 4, because 9 times 4 is 36. So we have 28x over 36 minus, we also have the same denominator here, so multiply by 4. 4 times 4 is 16, so minus 16x over 36. And alternately, 4 times 9 is 36, so we multiply this by 9. So 9 over 36 plus, and then 12 times 3 is 36, so we multiply this by 3. So 15 over 36. But note that if we have these common denominators, we don't even need to consider the denominators. We can just cross them all out and just consider all of these numerators. Thus, we can rewrite this as 28x minus 16x equals 9 plus 15. And if we simplify this, 28x minus 16x, that's just 12x. And 9 plus 15, that's just 24. And we want to solve for x because that's what the question asks. So 12x equals 24. If we divide both sides by 12, we have that x equals 2. And that is our final answer. Question 18 gives us a geometric problem that says two isosceles triangles are shown above if 180 minus z equals 2y and y equals 75, what is the value of x? We can just rewrite this as, rewrite this up here, minus z equals 2y, y equals 75. So because this expression equals 2y, and we know the value of y, we can just plug that in for y here. So we can rewrite this as 180 minus z equals 2 times y, and we said y is 75. And just simplifying this really quick, 180 minus z equals 2 times 75, which is 150. And we can continue and solve for z. So if we subtract 150 from both sides, we get that 30 minus z equals 0. And then we add z to both sides to get that z equals 30. But if you look at the question, that's not what it's actually asking. It's asking for the value of x, right? So we have z equals 30 here. And we know that this angle and that angle are equal because their side lengths are equal, right? So the base angle of this triangle is just 180, which is the total number of degrees in a triangle, minus 30, which is the top angle z. And because these angles are equal, we divide by 2. So 180 minus 30 is 150, and divided by 2 is 75. So these angles right here are 75 degrees. But we want to find x, so how do we do that? Note that this angle and x are related, they're all on the same straight line. And what is the number of degrees like this, or like that, on a straight line? It's 180, right? So this angle x is just 180 minus 75. This interior angle here, which is just 105 degrees. So x equals 105 degrees. 19, second to last question. At a lunch stand, each hamburger has 50 more calories than each order of fries. If 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does a hamburger have? So this definitely looks like another common systems of equation questions, but the system itself is not explicitly given to us, we have to formulate it. So, and we also don't have defined variables yet, so let's do that. So let's say h represents number of calories for a hamburger, h for hamburger, and let's say f represents the number of calories for fries, for an order of fries. Once again, f for fries. Thus, 2 hamburgers and 3 orders of fries have a total of 1,700 calories. We can rewrite that as 2h, 2 hamburgers, plus 3 fries, 3f, equals total 1700. But what about the other linear equation in our systems of equations? We can look at our question again and read this top line, which says, each hamburger has 50 more calories than each order of fries. So hamburger equals 50 more, so 50 plus an order of fries. Okay, so if we rewrite this, or actually this is pretty easy to just substitute into this equation. So using substitution, we have 2h, but we know h is 50 plus f, so 2 times 50 plus f plus 3f equals 1700. Expanding this left-hand term here, we have 2 times 50, which is 100, plus 2 times f, plus 3 times f equals 1700. If we combine like terms and get all the f's on one side, and then 2f plus 3f is just 5f. So we have that 5f equals 1600, right? So if we divide by 5 on both sides, because we want to isolate f, we get that f equals 320 calories. But we want to find h because the question asks how many calories does a hamburger have? And we just plug this, f equals 320, into this expression, and we have that h equals 50 plus 320, which is just 370 calories. Our final question, number 20. In a triangle ABC, the measure of angle B is 90 degrees. So we're looking at a right triangle. BC equals 16, AC equals 20. Triangle DEF, another triangle, is similar to triangle ABC, where vertices D, E, and F correspond to vertices A, B, and C, respectively. And each side of the triangle DEF is 1/3 of the length of the corresponding side of triangle ABC. And we want to find the value of sine F. So we have our triangle ABC with the right angle at angle B. So let's say that's angle B. Thus, line segment AC, we have AC is 20, which is our hypotenuse because it's the longest side of a right triangle, so this is 20. And BC is 16. And we want to find all legs of this triangle, right? So how do we find length AB? We use the Pythagorean theorem that says a squared plus b squared equals c squared. So AB equals, so in this case, we're actually solving for one of the base lengths, not the hypotenuse, so we can rewrite a squared plus b squared equals c squared to c squared minus b squared equals a squared. So 20 squared, which is our hypotenuse, minus 16 squared, which is one of our base lengths, equals, and then equals a squared. So we take the square root of each of these. So 20 squared is 400, and 16 squared is 256. So we take the square root of this subtraction, and the square root, so let's see. So 400 minus 256, what is that? That's 144. So we take the square root of 144, which you should know is 12. So this length right here is 12. Note you also could have solved this as a 3, 4, 5 right triangle, like using a proportion to a 3, 4, 5 right triangle, but we didn't do that, so I'll just move on to triangle DEF. So we know triangle DEF is similar to triangle ABC, and each of its vertexes corresponds to each of ABC's vertexes, with vertex F corresponding to vertex C. So draw that there, right? And that means vertex E corresponds to vertex B, and vertex D corresponds to vertex A. And what are we trying to find? We're trying to find the value of sine F. Sine F, which is this. So the sine of this angle. And note, because these are similar triangles, we're basically trying to find sine of this angle C. And what do we know about sine? So using SO, CA, TOA, sine is opposite over hypotenuse, right? And we don't even need to know the lengths of these triangles, or the length of the sides of DEF, because it's similar to triangle ABC, so that means the sine of C will equal the sine of F. So opposite over hypotenuse for triangle ABC is, so opposite to this angle is side length AB, and the hypotenuse is side length AC. So we have AB over AC, and AB is 12, while AC is 20. So sine F equals 12 over 20, or if we simplify this, 3/5. And that is our final answer. Thanks for watching.